suppose secant theta equals 4. Determine the exact values for the other trig ratios from 0 degrees to 180 degrees. So this is the first question. We're dealing with a reciprocal trig function. In grade 10 and 11, trigonometry was sine of theta, cos of theta, and tan of theta. In grade 12, we add secant of theta, cosecant of theta, and cotangent of theta. And each of these reciprocal ones is related to one of the regular ones. So for secant theta, if we have secant theta is equal to 4, and you know that secant of theta is equal to 1 over cos of theta, then we're going to use a shortcut and be able to write right away that cos of theta is 1 over 4. In other words, we're taking the answer of secant of theta, which is 4 over 1, and we're able to write cos of theta as just the reciprocal, because that's what reciprocal does. It flips the fraction. It's 1 over 4. This is a shortcut that we're going to use over and over and over again. If you want to see why it works, you would have to use what I wrote in the brackets. If secant theta is 1 over cos, I could rewrite this, and instead of writing secant theta, I could write 1 over cos theta is equal to 4 over 1. And if I wanted to get cos by itself, my next step would be, well, cos is in the bottom of my fraction. I could multiply both sides by cos. That would get me 1 equals 4 cos theta. And then if I wanted cos theta by itself, I would have to divide both sides by 4. So this is showing all the math. But since they're reciprocals of each other, we're going to use the shortcut where if you know secant of theta is 4 over 1, that means you automatically know that cos of theta is 1 over 4. And what's the nice thing about writing cos of theta is then you can go back to your grade 11 math. For example, if you know that cos of theta is 1 over 4, then according to your cast rule, since it's positive, you know that it's not in quadrant 2, it's not in quadrant 3, it would be either in quadrant 4 or quadrant 1. Now for part A, they just say determine the exact values of the other trig ratios from 0 to 180 degrees. Can you see that would be looking only in quadrant 1 and quadrant 2? So if I drew a picture of this right now, I know that my angle is in quadrant 1. I could draw a triangle back to my nearest x-axis. We always draw it back to the nearest x-axis so that we can label a reference angle. And I would now know that since cos is 1 over 4, I could label that adjacent over hypotenuse has to be 1 over 4. So the adjacent side's 1, my hypotenuse is 4. And I said you get really good at a squared plus b squared equals c squared. What number goes inside the square root? Don't say it out loud. Just write it down on your paper. Did you get 15? Because the hypotenuse is 4. 4 squared would be 16. This side, 1 squared would be 1. And I would need 1 plus 15 to equal 16. So 4 squared is 16, minus 1 gives me 15. That means that my opposite side has to be the square root of 15. And once I've drawn the triangle, I can now figure out sine of theta. Because sine of theta is opposite over hypotenuse. Root 15 over 4. And this is where, if you know sine of theta, cosecant will just be the reciprocal, using that shortcut. And from here, I know tan of theta opposite over adjacent. And so if I know tan of theta, I can use the shortcut and write cotangent of theta. So you're going to do lots of a squared plus b squared equals c squared this year, finding that square root of 15. And once you have that triangle, then it's easy to write sine of theta, cos of theta, tan of theta. And now we've added onto that all of our reciprocal ones. So you have to remember that secant goes with cos. Cosecant goes with sine. This one's the easiest to remember, that cotangent goes with tangent. Don't you wish they would have done something like that for, instead of calling it cosecant, they should have called it cosecant sine. If they would have just added the word sine at the end of it, you'd remember. And this one could be secant cosine, and then you'd remember. But that's why cotangent is so easy to remember. And then it's going to bother you that the C goes with the S and the S goes with the C. Or maybe that's how you're going to remember it, that they go with the opposite first letter. Sometimes that's helpful for remembering things. Now in part B, this, can you put a star or maybe three, maybe 5 stars? This is a super important question. Because this is what trigonometry is all about. Trigonometry is about solving for angles. And you've been building on that since grade 10. So this question says, if you had secant theta equals 4, and they want us to solve over the domain of negative 360 degrees, less than or equal to theta, less than or equal to 360 degrees. First of all, what you would do in a question like this is you would say, let's change it to one of the ones I know, cos of theta. And just like we did for part A, you would then think about your cast rule and say it can't be in quadrants 2 and 3 because cos is positive, so it has to be in quadrants 1 or 4. And unlike the first example, since our domain goes from negative 360 to 360, it will include answers in quadrant 1. It will also include answers in quadrant 4. With that in mind, we can draw an angle in quadrant 1. We can draw an angle in quadrant 4. With both of them, we make a triangle back to the nearest x-axis so that we can label our reference angle. And on both of them, you know that adjacent over hypotenuse is 1 over 4. In fact, I've drawn the exact same triangle twice. Once in quadrant 1 and once in quadrant 4. And once you've drawn a triangle, you can go back to grade 10 math. Grade 10 math for trigonometry was SOHCAHTOA. SOHCAHTOA always dealt with triangles. So when I look at my triangle now, I have a reference angle in that triangle. Whether, doesn't matter which one I use, I could now write cos of my reference angle is 1 over 4. That's based on what I see in that triangle. And if I have this, I can find my reference angle because in grade 10, to find an angle, you use cos inverse. And I get 75.5. Does it say to round to nearest something? It says round to the nearest degree. So if I round to my nearest degree, I get 76 degrees. So that's finding your reference angle. But we haven't found theta yet. And if we look at the domain for this question, I'm going to write beside this domain, when thinking about your circle, because an angle always starts at the positive x-axis in standard position, an angle always starts at 0. Right? If I want to do 75 degrees, I'd start at 0, go to 75 degrees. If I want to do negative 100 degrees, I'd start at 0, and I'd go in the opposite direction, 100 degrees. So when you get a domain that says from negative 360 to 360, you'll find it easier if your brain splits this up into positive angles and negative angles. Positive angles would be 0 degrees to 360 degrees, and negative angles would be 0 degrees to negative 360 degrees. And we'll do each of these separately when drawing a picture, starting with the positive ones. So this is what I have so far. I've got my two diagrams. If I want to find the actual angle, starting at 0 in the positive direction, this would be 1, and this would be the other one. And I hope that you can see, in quadrant 1, this angle theta is exactly the same as the reference angle. So that's a really easy one to write. It's going to be 76 degrees. But the positive one in quadrant 4, I have to figure out how big this is, but I know my reference angle is equal to 76 degrees. So thinking about this, well, all the way around is 360. That would have gone 76 too far, so I can figure this angle out by taking 360 degrees and subtracting 76 degrees. What does that leave me with? 284 degrees. And that's figured out the positive angles from 0 to 360. I also need to figure out my negative angles. So I'm going to switch to a red pen. And you see that this negative angle would look like this. And this negative angle would look like that. Quadrant 4 one is going to be really easy. Can you see that the negative angle in quadrant 4 is going to be identical to the reference angle, but when we're writing it, we would write it as negative 76 degrees. And the way that I figure out negative angles is very similar to the way that I figure out positive angles. I would think to myself, well, if I want to figure out how long this red angle is, all the way around would be 360. That would be too much. I'd have to subtract my reference angle. So the same as I did in green, I would think 360, subtract my reference angle, but I know that whatever answer I get has to be negative because it's a negative angle. So I still, even when working with negative angles, I still think about positive numbers. I still thought about going all the way around being 360, subtract my reference angle, and, oh, when I did that, I'm going to be like, well, it's going to be exactly the same as the positive one. So it'll be negative 284 degrees. The only difference is it's negative and the other one was positive. So we were able to, we looked. The only thing new from trigonometry from previous years was this first part that we changed secant to cos. Okay? Also a little bit new for grade 12 is grade 11 usually stayed between 0 and 360. Grade 12 expands that to whatever. So this one happened to be negative 360 to 360. But you'll find that grade 12 also likes to do between 0 and 360 degrees a lot. So it's very similar to grade 11. Because as soon as I change this to cos of theta equals 1 over 4, Your cast rule is from grade 11. Drawing the pictures in the right quadrants, then, that's from grade 11. Figuring out your reference angle from the triangle is actually a bit of grade 10 and grade 11. Because it's grade 10 because you've got an actual triangle now. As soon as you have a physical actual triangle, you're doing grade 10 trigonometry. But in the physical actual triangle, the angle we had was the reference angle instead of the actual angle. Dealing with reference angles is grade 11 now. Once you have your reference angle, you can draw the pictures and you can see what the actual angle is. And we had to go, this is why I broke it up in positive and negative. That's a little bit of grade 12, thinking about more than just 0 to 360 degrees. But what makes these questions difficult is you have to understand all this math from all your previous years. And some of us have forgotten some of them. So these are very important questions. In fact, I'm going to get you to turn to page, I think you have a blank page on page 482. This is so important. I'm going to do one more. Okay? And I'm going to, part of the reason I'm doing one more is sometimes they say in order to learn something well, you have to have done it at least 7 times. The unfortunate thing about our math class is each of the examples that we do, I give you usually just one example. That means you would have to do 6 more on your own before you would be ready to say, I know this, and I know this well. And what usually happens in a math class is people don't take the time to do some of the homework, and then they've only done a question 2 or 3 times, and they wonder, well, why don't I know how to do this for the test? You actually need to do lots of practice. So let's do another one together, because this kind of question is so important. We'll do solve for theta. Cosecant of theta is negative 5 over 3, 0. This one I'll just do once around the circle in the positive direction, from 0 to 360 degrees. So the first thing, from grade 12, you would see cosecant and say, if I know cosecant, then I know sine. So I now know that sine of theta is the reciprocal, negative 3 over 5. Then if I would go to my grade 11 math and I would say, well, according to my cast rule, if sine is negative, it's not in quadrant 1 or quadrant 2. It has to be in quadrant 3 and quadrant 4. And so I can draw a picture of the angle in quadrant 3 or quadrant 4. And with both of them, I can go back to my nearest x-axis, because then I can label my reference angle. And if I label that triangle, if sine of theta is negative 3/5, that means for my reference angle, I know 2 of the sides. Since sine is the opposite over hypotenuse, I can label my opposite as 3, my hypotenuse as 5, on both of them. And you'll notice when I do the math here, I actually label it as positive 3 and positive 5, because I'm thinking of an actual triangle with actual lengths. You will see sometimes in textbooks, they will label the 3 as minus 3 because it's going down. I actually prefer to label it as all positive values, because on a triangle, if you have actual lengths, you can't have a length of something being minus 3. Its length is 3. And that's also important because when you're solving for a reference angle, and this is something from grade 11, a review. So now when I set up my equation for my reference angle, of course, it's also 3/5. But for reference angles, when you're solving for a reference angle, the ratio is always positive because you're going back to grade 10 math and dealing with an actual triangle of actual lengths. And this is an area that students often make a mistake because they want to find the angle too quickly instead of finding the reference angle first. So when I'm finding a reference angle, it's always positive. Now I can find my reference angle by doing sine inverse of 3/5. Go to my calculator. The nearest degree would be 37 degrees. There's my reference angle. I want to find the angle theta in standard position, so I need to start here. Only from 0 to 360, so I'm only going positive. There would be one. There would be the other one. Eventually, some people don't draw the diagrams, okay? The diagrams, though, if you're not drawing them, I expect you to draw them in your heads, because this is key to understanding. In fact, some people, maybe in grade 11, you memorized a formula for finding the angle if it's in quadrant 3. I hope that if you draw the picture, it just makes sense. If we can have things make sense and we're not memorizing them, that saves your brain for you. Like, you will have to memorize a lot of stuff in grade 12 in all of your classes. You'll have to know a lot of stuff. And I kind of think of your memory kind of like it only has so much space. Have you ever had a test where you had way too much to remember and you couldn't remember something, right? Tests would be super easy if you just had to memorize one thing, right? We're going to change our test on Friday. Friday's test, you just have to remember the number 32. Get your test. The question is, what was the number? Right, 32, 100%. Wouldn't that be like, yes, I want that test. That test would be easy because you have one thing to remember. Okay? Next week, I will have another test. I'm going to give you 112 different numbers, and you have to write them down in the right order. How hard would that test be? Well, it depends, right? If the numbers were 1, 2, 3, 4, 5, 6, all the way to 112, you'd be like, no problem. But if they were random numbers, you would take some memory, right? Just one number, 32, fine. So if there are things that we can understand instead of having to memorize, that'll save our brain for other things, because you will have to memorize some stuff. In this case, does it make sense that if I wanted to find this whole angle, well, up to here is 180, and then I'm going to have to go, my reference angle is 37 degrees more. That should make sense to you. And if it makes sense to you, you never have to remember, oh, quadrant 3 was 180 plus my reference angle and memorize that formula. No. Just have it make sense. Save your memory for other things. This angle will be 217 degrees. Same thing. If you think about it logically for quadrant 4, all the way around would be 360. That's too much. I would have to subtract my reference angle. Subtract 37. That leaves me with 323 degrees. Questions for practice on this one? 9, 10, and 11.